Hello everybody, my name's James and welcome to Cambridge University where I work. Which could mean anything, that could mean I'm the janitor, but it's even better than that. You see, I'm a mathematician. And I know what you're thinking, surely he's far too young and handsome to be a mathematician, right? Okay, suit yourselves. But no, and today I'm going to show you a problem, and I thought I'd do it somewhere more academic. So the problem I'm going to show you today is called the utilities problem, and it works like this. There are three houses, and I want to connect the gas, the electricity and the water to these three houses. I connect them by drawing a line. And I want to know is, can I do this without crossing a line? Now if you haven't seen this problem before, you might want to pause the video now and have a go, because I'm going to give the solution. So, if you're ready, I can tell you that this is impossible, and I can prove it's impossible too. And perhaps later I'll show you a way around it. But to prove that it's impossible, the first thing I'm going to do is I'm going to reduce these houses so that they're points. So it looks something like this. Now I want to connect these three red dots to these three blue dots without crossing a line. So it might look something like this. Well, except you can see here that I have crossed a line. Now this is called a graph. Feel free to move the points about, to move the lines about, and the question still holds, can I do this without crossing a line? Well, if I can do it without crossing a line, then I can turn that flat two-dimensional graph into a three-dimensional solid, just by inflating it. So I can take something flat and I can go and turn it into a three-dimensional solid. Now, there's a rule that we know about three-dimensional solids. It's called Euler's formula. It was discovered by the Swiss mathematician Leonhard Euler, and it looks like this. It says that the number of faces plus the number of vertices, that's the number of corners, take away the number of edges, will always equal 2. This is a normal solid with no holes in it or anything like that. So for example, for this object here, it's called an octahedron. It has 8 faces, it has 6 corners, and it has 12 edges. If I put that into Euler's formula, it looks like this. So it says 8 plus 6 minus 12 equals 2, which it should, and that's what I expect. By the way, just as an aside, I can use Euler's formula to work out that there are only 5 regular solids. A regular solid is like this. It has the same number of faces at each corner. The 5 solids are called the tetrahedron, the cube, which you probably know, the octahedron, which we just saw, the dodecahedron, and the icosahedron. There are only 5 regular solids. But to get back to the problem, now this graph that we're going to inflate and turn into a solid, when it has 6 corners and it has 9 edges. So if I put that into Euler's formula, I can say that the number of faces is 2 plus 9 minus 6, which is 5. There are 5 faces. Now there's one thing I know about this solid. I know that I never connect 2 houses together, and I never connect 2 utilities companies together. There's no point. So I can say that each face has at least 4 edges. So that means that if there's 5 faces, there must be at least 20 edges. But I've counted each edge twice there. Each edge is connected to 2 faces. So I can say I need at least 10 edges, but I only have 9, and that's why it's impossible. By the way, I said I was going to show you a way around it. Imagine this. Imagine if you can go off this side here and reappear at the opposite side, like an old computer game, then you can connect the houses. Imagine this. If I roll this up into a tube like that, and then if I connected the 2 ends of the tube so it made a big round donut-like shape, then yes, I can connect the houses. This is only excluded from the Euler's formula because it has a hole in it. And I said Euler's formula works for solids that don't have a hole in it. And that's how you do it. So if you have been, thanks for watching.